So in this next section, we're going to take a look at arithmetic series. Now we've already been over arithmetic sequences when we talked about 3, 6, 9, 12, and on and on and on. And you can see that we've got a common difference of 3 for this sequence. Now this is known as an infinite sequence because since we have this ellipse or the 3 dots, that means that it is going to go into infinity. Now we can take that sequence and turn it into a series by adding all of the numbers in the sequence together. Now, when we have an infinite series, we know that our solution is going to be an infinite number because there is no last number in that sequence. We also have something called a finite sequence. So you can see in this example, we've got 3, 6, 9, and 12. Still a common difference of 3, but we don't have an ellipse after the number 12. That means that the sequence is going to end at 12. With 3, 6, 9, and 12, if we're adding these together, we could do this pretty easily in our heads, or there's few enough numbers that we could plug them into a calculator and get an answer for that. But what if we don't have a small number of terms in our sequence or a small number of terms in our series? Then it's going to be more difficult to figure out what the sum is. So that's where we come in with this formula here. This is the formula for the sum of a finite series. And anytime you see the Greek letter sigma, you know that that means sum, or the answer to an addition problem. So our formula is S sub n equals n over 2 times a sub 1 plus a sub n. So we're going to take the first term in the series, add it to the last term in the series, and then we're going to multiply that by the number of terms in the series divided by 2. And that is going to give us the sum of our finite series. We're going to apply what we just learned to solve problem number 1. So in this problem, it's asking us what is the sum of the even integers from 2 to 100. So you could draw this out as 2 plus 4 plus 6 plus all the way out to 100. Now you've got a lot of terms there, so if you're taking the SAT or you're working on a test or a homework assignment, you don't want to go 2 plus 4 plus 6 plus 8 plus 10 plus 12 and on and on and on until you reach 100. It's just going to take you too much time. So let's use the formula to get us there. But before we can use that formula, which is again going to be S sub n is equal to n over 2 times an plus a1. So we can use this formula, but before we can use that, we've got to figure out what this n value is. Because right now we've got 4 variables. We've got S sub n, we've got n, we've got a sub n, and we've got a sub 1. We need to get 3 of the variables before we can figure out what the 4th is. So right now we know that a sub n is the last number in the sequence, or the last number in the series. That's going to be 100. We know that a sub 1 is the first number in the series or sequence, so that's 2. What we're looking for is the sum, so we need to get this number here. The way that we're going to do this is to use either one of these 2 equations. Both of these equations are the same thing. The only difference is we're solving for a different variable with these equations. So what we want to do, I'm going to use this one right here. The n equals a sub n minus a sub 1 over d plus 1. And the reason why I'm going to do that is because I've got everything, all of my information that I have is over on this side, and I'm looking for this n. So we know that the last digit is going to be 100. So we get 100 minus the first digit in the sequence. So 100 minus 2 over our common difference. Remember that d is our common difference. So 2 to 4 is 2, 4 to 6 is 2. So we've got a common difference of 2. So we're going to divide this result by 2, and then we're going to add 1 to that result. So 100 minus 2 is 98. Divided by 2 is 49, plus 1 is 50. So what we know is we have 50 terms in this series right here. So now we can come back over to this equation here, and we can start filling in our variables. So we've got S sub n is equal to 50 over 2 times a sub n, which is 100, plus a sub 1, which is 2. So now we get 50 divided by 2 is going to be 25. And then 100 plus 2 is 102. And so that's going to leave us with, I believe it's 2550 as our solution. So yes, we're going to get S, the sum of this series of numbers is going to be 2,550. The next thing that we're going to take a look at is how to write a limit. Now, what we're going to do to write a limit is we're going to start with the Greek letter sigma, which again means sum. So go ahead and write a big sigma on your paper. Then we're going to add 3 pieces to that Greek letter sigma. The first piece is going to be a number that goes above the sigma. And that number that goes above the sigma is going to be the number of total terms in the sequence or in that series. There's also going to be something that goes below the sigma, and that's going to be the starting value of n in the explicit formula that you're going to put to the right of the sigma. We'll get to that in just a second. To write that value, you're actually going to write n equals a number, and that's going to be the first number in that series. So this will make a little bit more sense when we do the example problem, but your 3 pieces after you write the sigma is just one number to indicate the number of terms in the series. Then you write the explicit formula for how to get from one number to the next in the series or sequence. And then you write n equals the starting value of the number in the explicit formula. In problem number 3, we want to write the limit for the series that begins with 7 and ends with 207. Before we can write that limit, what we've got to do is we've got to establish what are some of these terms that we've got. So our a sub 1 is equal to 7, our a sub n is equal to 207, and our d is equal to 4. Our common difference is 4 because 7 plus 4 is 11, 11 plus 4 is 15, and on and on and on. So what we're going to do first is we're going to establish our explicit formula, which will go to the right of our sigma. And with this, we're just going to leave this a sub n alone. We're not actually going to fill that in with 207. Just leave that as is. We'll work on the right side of this formula. So a sub 1 is 7, and then we add that to n minus 1 times our difference, 4. So now we work that out, and we get 7 plus 4n minus 4, and then combine like terms, so we get 4n plus 3. So this right here, this is our explicit formula. So we want to, again, we're going to put that to the right of our sigma when it comes time to write our limit. The next thing we need to do is we need to establish what are the number of terms that we've got in this sequence or series. So again, we're going to start with the last number, or the last term in our series, and that's going to be 207. So we're going to go 207 minus a sub 1, so minus 7, divided by the common difference d, and then plus 1. So 207 minus 7 is 200, divided by 4 is 50, plus 1 gives us 51 for our n value. Okay, so now that we've got all that, we can actually begin to write what our limiting notation is going to look like. So we're going to start with our sigma, and then we want to put the value that n is above it. So we know that there are 51 total terms in this sequence or series. The next thing we're going to do is to the right of sigma, we're going to write in our explicit formula. So 4n plus 3. Then we write n equals below the sigma. And what we want to do here is we want to put in the first value of this n that gives us that number. So basically, this becomes 4n plus 3 equals 7. So we get 4n equals 4 and n equals 1. So we put n equals 1 right there. And this is the notation for our limit.